Okay, let's go into example 1. So what we're going to do is we're going to consider this H matrix, which is a 3x2 matrix. Okay, it is okay. So because it's a 3x2 matrix, any map that it defines must carry a dimension 2 domain to a dimension 3 codomain. So it has to go through from 2-dimensional to 3-dimensional. So we could choose how we want to do that. So in this case, we could choose the codomain to be our the domain to be R2 and the codomain to be P2. And we could use these bases to do it. Oops. That should be closed. Okay. So B is going to be these two bases, or actually this basis, I should say, with these two basis vectors. Okay. And then D for the codomain will be represented by these three vectors, or not vectors, but polynomials in the basis. And so now what we're going to do is we're going to let H be the mapping from R2 to P3, be the function defined by H. Okay, so that we're going to use H. Okay, now what we're going to do is we're going to compute the image under H of this member of the domain. So we're going to take this vector in the domain and we're going to use H to compute the image. And it's pretty straightforward. Okay, so let's do that. I'll just erase this middle piece here. So, okay, so now what we're going to do is we're going to take our vector and we're going to write the representation with respect to D of H of V. Okay? And that's going to be H times, right? That's going to be H times the representation with respect to B of what? Of V. Okay? So now, we've got 3, 2. So in other words, with respect to B, we've got to write this vector, right? So the representation, we're going to take these basis vectors, right? And we got to find those coefficients. And so when we do that, again, I'm going to leave it to you, but what we're going to get is we're going to get this matrix here. So it's going to be 1, 2, 3, 4, 5, 6 times, in this case, it's going to be a 2 high vector, and it's going to be -1/2, -5/2. Okay. And you can see if you go backwards that if you take -1/2 times this plus -5/2 times this, you get -3 and so on. So you can see that it works. So we're just using what we used before. So now we've got these two matrices, and now we just do our multiplication. Okay, and so when we do that, we're going to get a negative 11 halves, a negative 23 halves, and a negative 35 halves. Okay, and that's the representation with respect to D of the image. Now, from its representation, computation of H of V is routine. Because all we're going to do now is, again, this is this, right? So how do we do that? Well, from here, it's, oh, hold on, D. So now what we're going to do is, now to go one step further, we can write this as negative 11 halves times x squared minus 23 halves times x squared plus x minus 35 halves times x squared plus x plus 1. And so the end result, when we simplify this, is negative 69 halves times x2 okay, again, we're distributing and combining like terms. And then the second term is going to be minus 58 halves times x squared or no. No. Negative 58 halves times x, and then of course minus 35 halves. Okay. Because that's the only constant term. So again, we're just distributing and combining like terms, and so this is what we get as a result. And that's it. So now what we're going to do is we're going to introduce a theorem.